The National Electrical Code, or NEC, permits the use of reduced neutrals in specific situations. A reduced neutral refers to a neutral conductor that is smaller in size compared to the phase conductors. According to the NEC, the sizing of a reduced neutral must comply with Article 220.61. The application of a reduced neutral is limited to scenarios involving nonlinear loads, which are characterized by an equal current draw across all phases. Additionally, the installation of the reduced neutral necessitates its placement within a raceway that is exclusively dedicated to these conductors and not shared with others. In the context of wire sizes, the Electrical Supply House's recommendations for a 100 amp service align with the NEC conductor ampacity table. Specifically, they suggest using number 2 aluminum wire with an ampacity of 100 amps for the phase conductors. For the neutral conductor, they propose number 4 aluminum wire with an ampacity of 65 amps. And for the ground conductor, they advise using number 4 copper wire, also with an ampacity of 65 amps. The justification for employing a reduced neutral stems from the understanding that the load will not exhibit a significant level of balanced current distribution across all three phases. Pole barns, for instance, typically feature motors and various other loads that draw more current from one phase compared to others. Consequently, the neutral conductor experiences a lower current load in comparison to the phase conductors. By opting for a reduced neutral, cost savings can be realized in terms of both materials and labor, without undermining the safety or operational integrity of the electrical system. Article 220.61 of the NEC provides guidance on determining the neutral conductor size. It outlines different methods depending on the type of load being served. For household ranges and similar appliances, a demand factor can be applied to reduce the neutral load. For other types of loads, the neutral conductor must be sized to carry the maximum unbalanced load. The NEC specifies minimum ampacities for conductors based on their size and material. For example, number 2 aluminum wire typically has an ampacity of 100 amps when installed in accordance with NEC guidelines. Number 4 aluminum wire typically has an ampacity of 65 amps under similar conditions. Number 4 copper wire also typically has an ampacity of 65 amps. These ampacities are based on certain assumptions about ambient temperature and the number of conductors in a raceway or cable. If the actual conditions are different, the ampacity may need to be adjusted. The NEC provides tables and guidelines for making these adjustments. When selecting wire sizes, it is important to consider not only the ampacity but also the voltage drop. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. The amount of voltage drop depends on the length of the circuit, the current flowing through the conductors, and the resistance of the conductors. Larger conductors have lower resistance and therefore result in less voltage drop. In the situation described, the distance between the main panel and the pole barn is 120 feet. This is a significant distance, and voltage drop should be carefully considered when selecting wire sizes. To calculate the voltage drop, you can use the following formula: voltage drop equals 2 times K times I times D divided by Cm, where K is the direct current constant for the conductor material, which is approximately 12.9 ohms circular mils per foot for copper and 21.2 ohms circular mils per foot for aluminum. I is the current in amps, D is the one-way distance in feet, and Cm is the circular mils area of the conductor. For number 2 aluminum wire, the circular mils area is approximately 66,360 circular mils. For number 4 aluminum wire, the circular mils area is approximately 41,740 circular mils. For number 4 copper wire, the circular mils area is approximately 41,740 circular mils. Using these values, you can calculate the voltage drop for different wire sizes and determine whether they meet the NEC recommendations. In addition to the NEC requirements, it is also important to follow any local electrical code or regulations. Local codes may have additional requirements or restrictions on the use of reduced neutrals or the sizing of conductors. It is always a good idea to consult with a qualified electrician to ensure that your electrical system is safe and compliant with all applicable codes. They can help you select the appropriate wire sizes and ensure that the installation is done correctly. When installing electrical wiring, it is important to follow safe work practices. Always disconnect the power before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and eye protection. And be sure to test your work after you have finished to ensure that it is safe. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest NEC requirements to ensure that your electrical system is safe and compliant. Many resources are available to help you learn more about the NEC. The National Fire Protection Association, or NFPA, publishes the NEC and offers training courses and other educational materials. Many electrical supply houses and trade organizations also offer training on the NEC. By taking the time to learn about the NEC, you can ensure that your electrical system is safe and reliable. The use of a reduced neutral can be a cost-effective way to save money on materials and labor. However, it is important to understand the NEC requirements and to ensure that the installation is done correctly. By following the NEC and consulting with a qualified electrician, you can ensure that your electrical system is safe and compliant. When considering the installation of a 100 amp service to a pole barn, several factors must be taken into account. Firstly, the distance of 120 feet from the main panel to the pole barn necessitates careful consideration of voltage drop. Secondly, the type of loads to be served in the pole barn needs to be assessed to determine the appropriate neutral conductor size. Thirdly, compliance with the NEC and any local electrical codes is paramount for safety and regulatory adherence. The recommendation of number 2 aluminum wire for the phase conductors, number 4 aluminum wire for the neutral conductor, and number 4 copper wire for the grounding conductor appears to be a reasonable starting point. However, a thorough analysis of the anticipated loads and a voltage drop calculation are essential to validate the suitability of these wire sizes. If the pole barn is expected to house equipment with significant nonlinear loads, such as variable frequency drives or electronic lighting ballasts, the neutral conductor may need to be sized larger than the reduced size suggested by the electrical supply house. Nonlinear loads can generate harmonic currents that flow in the neutral conductor, potentially overloading it if it is not adequately sized. In such cases, the NEC may require the neutral conductor to be the same size as the phase conductors. To accurately determine the neutral conductor size, it is necessary to calculate the maximum unbalanced load that the neutral conductor will be subjected to. This calculation involves considering the loads on each phase and determining the maximum difference between the currents flowing in each phase. The neutral conductor must be sized to carry this maximum unbalanced current. Voltage drop is another critical factor to consider when selecting wire sizes, especially for longer distances. Excessive voltage drop can cause equipment to malfunction, reduce its efficiency, and potentially damage it. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To calculate the voltage drop, you can use the formula mentioned earlier. Voltage drop equals 2 times K times I times D divided by Cn. By plugging in the appropriate values for the conductor material, current, distance, and circular mills area, you can determine the voltage drop for different wire sizes. If the calculated voltage drop exceeds the recommended limits, you will need to increase the wire size to reduce the resistance and minimize the voltage drop. In addition to the NEC requirements and voltage drop considerations, it is also important to follow any local electrical codes or regulations. Local codes may have additional requirements or restrictions on the use of reduced neutrals or the sizing of conductors. It is always advisable to consult with a qualified electrician who is familiar with the local codes and can ensure that the electrical installation is compliant. A qualified electrician can also perform a load calculation to determine the total demand of the pole barn and ensure that the service is adequately sized. They can also inspect the existing main panel to ensure that it has sufficient capacity to handle the additional load of the pole barn. When installing the wiring, it is important to follow safe work practices. Always disconnect the power before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves, safety glasses, and insulated tools. And be sure to properly ground all electrical equipment to prevent electrical shock hazards. The grounding conductor plays a crucial role in providing a safe path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The grounding conductor should be sized in accordance with the NEC and should be properly connected to the grounding electrode system. In summary, when planning a 100 amp service to a pole barn, it is essential to consider the NEC requirements, voltage drop, local electrical codes, and safe work practices. Consulting with a qualified electrician is highly recommended to ensure that the electrical installation is safe, compliant, and meets the needs of the pole barn. The recommendation of number 2 aluminum wire for the phase conductors, number 4 aluminum wire for the neutral conductor, and number 4 copper wire for the grounding conductor is a reasonable starting point, but it should be validated by a thorough analysis of the anticipated loads and a voltage drop calculation. Remember to prioritize safety and compliance throughout the entire process.